Good afternoon, ladies and gentlemen, and hello to our colleagues in Brazil, to the folks in Embrapa. We can see you on the screen. We welcome you. To our colleagues at University of Pernambuco, and to our colleagues in the audience here in College Station. This is a continuation of our Water Without Boundaries seminar. We've had the first two speakers. This is our third speaker. We're extremely fortunate today to have a very distinguished professor, a Regents Professor at Texas A&M, which is, within academia at A&M, one of the highest honors you can earn. Dr. Bruce McCarl is in the Department of Agricultural Economics. Bruce has been here a number of years. I will say Bruce and I started a project almost 30 years ago now. It seems like only yesterday. But he's gone on to do wonderful things with water and agriculture. So he's going to speak today on the impact of climate change on agriculture. Let me just tell you a little bit about Dr. McCarl. When I think of traveling, I travel in the United States. Dr. McCarl is a world traveler. He was in Chile last week. I saw him, it was on Friday. He had just got back Thursday night. He was a little blurry-eyed. He had to teach an economics class. I make this point just because he's a world traveler. He's done extensive work, as I said, on climate change, water, and impact on agriculture from an adaptation to a mitigation standpoint. But importantly, he served on IPCC, the Intergovernmental Panel on Climate Change, and in 2007, this panel was awarded the Nobel Prize. So in a sense, Dr. McCarl is a Nobel Prize winner. And so that speaks to his reputation, the body of work that he's done. And he's a wonderful speaker, an entertaining speaker. And so please join me in welcoming Dr. Bruce McCarl.
Well, good afternoon. I admit I haven't been to Brazil lately, although I was working with a Brazilian student from Recife just recently, and I used to work with Embrapa. I worked there about 3 weeks in 1979. But about then, I started working on climate change. I actually started working on it in about 1983. And I think this is an important image here when you think about climate change. Climate change is a very involved issue. In the United States, greenhouse gases is thought of one of the things that are causing climate change. In the United States, 85% of the greenhouse gases come from energy consumption. In the long run, we're seeing effects from climate change. We can try to reduce those effects either by adapting and learning how to operate in warmer environments, or by mitigating where we reduce the greenhouse gas emissions. So basically, there's energy conservation activities or mitigation activities that reduce the future extent of climate change. We see the slow-moving effects, which is the bulldozer image, and we see the adaptation, which is something we can do to live better with those effects. But as I'll show you in a little while, some of those adaptations may involve abandoning certain lands or radically changing our agricultural enterprises. So I know that you had Jerry North, who gave a presentation 2 weeks ago. I was actually in Chile when he was talking, so I only know what he said by looking on paper. But I'm going to cover a little bit of the same ground, principally looking at big things that are affecting agriculture. I'm going to talk a little bit about why this is happening and then what kinds of decisions we can make. And then I'll inventory the issues of effects, mitigation, and adaptation. Now, I've been working on this for almost at least 20 years and actually closer to 30, so I could talk for about a week and a half. I'm only going to give you an overview of some of these things. So I'm sure Dr. North talked about this. The first picture there at the top is one from the IPCC. It shows temperature has globally been increasing. It also shows that the rate of that increase is accelerating. The red line is a 150-year trend. The yellow line is a 25-year trend, and notice the yellow line is steeper than the red line. And in fact, if you took a 10-year trend and put the most current data in it, you'd see that it's even steeper there. This is globally the 10 warmest years as they were stated by the NOAA, or I won't say what NOAA means. In the last 10 years have been 9 of the warmest years that we've observed in recorded history. 2010 was the warmest year. 2011, notice, is in 8th place here. They didn't have the data for 2011, but the thing you should notice from this is all but one observation starts with a 2000. So all of them were in the very recent past, and in fact, the one from the last century was in 1998. So all the warmer events have been in the last few years. When we look at what's happened during this year, this is a comparison of the warmest years in North American history, and notice up until August, this was running basically warmer than any year in history. So right at the moment, we're working on the next warmest year, at least in North American terms. Now, when it gets hotter, agriculture will be affected. Agriculture will be affected in a couple of different ways. We know, for example, in the United States, you can grow rice in this part of the country, but if you get to the far northern parts of the country, you start growing things like canola that won't satisfactorily grow here. The temperature will likely cause shifts in the bands where things can be grown. Precipitation is also an issue. When it gets hotter, we have greater amounts of adaptation, greater amounts of evaporation. I looked at the clock, which was a mistake. Greater amounts of evaporation, and we've seen globally greater precipitation. The real issue, though, is where will that precipitation occur and what form will it take? This is a truly hideous picture from the IPCC 2007 report. It's not blurry because I want it to be. It's blurry because it's not a good image in that report. But the blue areas in this report show areas where the intensity of rainfall is increasing. Now, if you think about agriculture, what that means is across a month, how much rain comes in the 3 wettest days, and we're seeing increasingly more in those time periods in most areas of the country and in a lot of areas there in Brazil. So basically, this is not a good development for agriculture. It means you get more of your rainfall from thunderstorms, less of it from the gentle frontal rains, which we need for agriculture. Drought. This is a graph from 1900 to 2002 of the shift in drought incidence. And notice there are areas in Africa and Brazil where, and some in North America, up in Canada, where droughts are getting worse. In Texas, it happens to be getting a little bit better across that whole time period. But I think the last 10 years would look somewhat different than this historical data. I haven't seen that particular graph. Also, the bottom little bar graph shows that the incidence of drought globally is increasing. So that's sort of the background for agriculture. It's currently hotter. We're currently seeing a little bit more rainfall. We're currently seeing more concentrated rain. We're currently seeing more droughts. If you went and looked, you could also find more extreme events. You could find an uneven distribution of rainfall where certain areas like Texas are having less, but certain areas further north are having more. So the question is, what's projected? Well, this is the projection graph from the IPCC 2007 report. They're actually is currently this graph from the brand new IPCC report, but it won't be released for a year. Plus, this graph gives different plausible futures. The red graph is what happens if we don't do much at all on mitigation. We just keep going the way we are. The green and purple lines there are various degrees of reduction in greenhouse gas emissions. The yellow graph down at the bottom is what happens if we stopped emitting right now. Notice even under the yellow graph, we expect the temperature to keep increasing because it takes a long time for the Earth to come into equilibrium, given that some factors have been applied. The other thing you should notice there is most of those lines, the upper ones, not the yellow one that stops emissions, basically don't show much reaction till the middle of the century. And I'll have a little more to say about that in a moment. But also the purple star is important because in that star, that shows where we are with respect to emissions the last few years. We're actually emitting faster and warming faster than the projections, any of the projections in the 2007 report. So climate change is proceeding at a more rapid rate than we thought it would be 5 or 6 years ago. This, I think, did Dr. North use this exact graph? I think he might have, although I'm not sure. But this shows areas where we expect it, how we expect the rainfall to change. And the browner areas in this picture are the areas where we expect greater drought, lesser incidence of rainfall. And generally, this is in what we call the subtropics. Notice that Texas is pretty vulnerable in the December, January, February panel on the left side, and Brazil is fairly vulnerable in the panel on the right side, which is June, July, and August. So this shows both of our countries are at some substantial amount of risk to be drier into the future. So the next question is why? Why are we seeing these kinds of dislocations in climate? Well, in the year 2000, U.S. National Climate Change Assessment, I was part of the agricultural part, they had this picture. And what this picture shows is the underlying reasons, which is the greenhouse effect. Namely, radiation comes in from the sun, hits the surface of the Earth, and is reflected back out into space. But if you have greenhouse gases, that serves as a mirror, and it reflects some of that radiation that ordinarily would have gone out into space back into the Earth system. Some of that holds heat. I remember back at the time that everybody was excited about the Nobel Peace Prize that the IPCC got, I had to go stand in the greenhouses across campus in January and have my picture taken, and it was nice and toasty in that room. The reason being that the sun's rays enter through the glass, hit the white surface, and they go to get reflected out, but the glass reflects things back in, so that greenhouse is warmer. Same sort of thing is happening with the climate and with the Earth. Atmospheric CO2 is one of the driving forces. Jerry, I'm sure, had a graph like this. I started working on climate change in the mid-'80s. At that particular point in time, the parts per million of carbon dioxide in the atmosphere was about 345. Right now, it's about 392. So we've changed the atmosphere more than 10% in a 25-year period. A pretty dramatic change when you consider the